Hello, this is my submission for Lab 3, the video report, where we're going to make a register. So I'm going to first talk about the three components that we're going to make. I'm going to show how they go together in a level 1 block diagram, and then I'm going to show you the test benches of them working. So the first part out of 3 we're going to talk about is the register. Register is going to have 4 inputs. It's going to have a load, a reset, and a clock, as well as a 32-bit D input and a 32-bit D output. Next, we got the decoder. The decoder is a 5x32 decoder. As you can see right here, it has 5 selector inputs, as well as all of these outputs right here. So this is just a level 0 block diagram. Next thing we got is the mux. The mux is going to have 32 inputs for each register. So we're going to have all the registers, you'll see that in the next part, and each one's going to have 32 inputs as well as the selector lines, and then you're going to have one output, which is the 32-bit mux output. So as I said, right here we got the level 1 block diagram. We've got a decoder. It's going to have a write address as well as an enable, and it's going to have its 5 select input lines. This is going to produce the outputs D through D31. And these are going to go into the equivalent register. So D0 will go into reg00. You're going to have 32 registers, and the outputs of these registers are going to go into the muxes. The muxes are then going to take in a read address that's equivalent to the mux that they are. So read address A, read address B, and those are going to provide mux outputs for our DA and DB. So going to the test bench, we have our decoder right here. So just give me 1 second. So for the decoder, we have our 5x32 decoder. At the top, let me see if I can scroll in really quick. So at the top up here, we have X31 going all the way down to X0. And then down here, we have our 5 input selector lines. So this ModelSim screenshot is going to show you the 5 selector input lines as well as the 5 input selector lines are going to be in binary, the rest is going to be correlating. So for example, if you were to have a binary number 11111 inputted into the decoder value is going to be outputted through X31 up here. So as you can see all that right there, it works perfectly how we'd expect it to. Next thing is the multiplexer. Let me pull it right there. So for the multiplexer, it's going to take 32 input signals with 32-bit width and 32 outputs, a 32-bit width output. This multiplexer couldn't be tested with 32 inputs, each with 32 bits, so the design was tested instead with 8 32-bit inputs. The simulation shows the multiplexer passing with values corresponding to the register addresses. So, for example, let's see. The value from input register I5 is 0000101, and when selector S equals 00101, as you can see, the output is 000000101. The selector and the output are shown in decimal for simplicity. Going on to the next part, let's talk about the register file we got right here. This is the test bench for our register file containing 32 registers that are 32 bits width. In this simulation, it first tests the reset and the enables, and then the test bench puts the data 047952B into register 1 and data ACE 13579 into register 2. Finally, we make the select for mux A to be register 1 and the select for mux B to be register 1. test bench shows that D out A, the output of MUX A, output 047952B. The test bench also is going to show the D output for B, the output of MUX B, which is ACE 13579. This photo essentially just shows that the test bench and the register works exactly how we'd want it to. That's everything.